Okay, everyone, the final problem of this section. We are doing the rational zero theorem again. So we're finding all the roots of this lovely polynomial and writing this thing in factored form. So I promise this one won't take as long as example 12. Okay, but also if you think you understood example 12 and you want to try example 13, go ahead, fast forward to the end and see if you got it correct. So we are trying to find all the zeros as well as write this thing in factored form. All right, let's go. We always start by doing P's, Q's, and P over Q's. Okay, which remember my P's come from the last term and my Q's come from the first term. All right, you guys, so everything that goes into 4, we got plus or minus 1. 1 times 4 goes into 4. 2 times 2 goes into 4, so plus or minus 2. And plus or minus 4, because 1 times 4. All right, my Q's. Okay, we write everything that goes into 4. Okay, so everything that goes into 4, same thing as these, because we just did 4. So plus or minus 1, plus or minus 2, and plus or minus 4. All right, guys, now, this is the most important part. This gives us our list of potential zeros. Okay, so I'm going to take all my P's and divide by all my Q's. So 1 divided by 1 is 1, plus or minus 1. 1 divided by 2 is plus or minus 1/2. 1 divided by 4 is plus or minus 1/4. All right, 1's done. All right, 2 divided by 1 is 2. 2 divided by 2 is 1, but I already have it. And 2 divided by 4 is 2/4, and that reduces down to 1/2, so I don't have to write that. So bam, that one's done. 4 divided by 1 is 4. 4 divided by 2 is 2, but I already have that, so I don't got to write it. And 4 divided by 4 is 1, but I don't have to write it. Okay, so this is my P over Q list. So I'm going to kind of ignore everything before this because it doesn't matter. All I care about now is this lovely P over Q list because this is going to be my list of potential zeros. So remember, these are the numbers that we put in our box. Okay, and remember, if we get a remainder of 0, we have found a 0, which means we can write this in factored form. So let's see, out of all my P over Q's, what looks good, you guys? What do you think will give us a 0? Some of my students are like really good at guessing zeros, so let's see if you're good at guessing. Let's see. I agree, you guys. I'm feeling really good about -1/4. I'm feeling that one too. We think so much alike, you guys. Okay, so I'm going to put my -1/4 in the boxy. Remember, these are my zeros in the box. This is not the factored form. This is the 0. Factored form, we have to switch this sign. Okay, let's see what happens. All right, guys, so in synthetic division, we start with our highest exponent and go down by 1 each time. So x to the third, x squared, x to the first, and x to the 0. And I'm going to write all my coefficients. So I got 4. 1 is secretly in front of the x squared, 16, and 4. All right, let's do this thing. All right, bring down the 4. 4 times -1/4. Now, when you have 1/4, that's like dividing by 4. Okay, and since we have a negative, it's like dividing by -4. So 4 divided by -4 is -1. So I'm writing -1. 1 minus 1 is 0. 0 times 1/4 or -1/4 is 0. 16 plus 0 is 16. 16 divided by -4 is -4. Holy hot dog, 4 minus 4 is 0. You guys are so good at guessing zeros. We found it on the first try. Man, you guys are awesome. So yay, this tells us we have a factor. Yay! Which means that this is a 0. Okay, so our 0 is x equals -1/4. Okay, now, at the bottom, well, let's see. Yeah, at the bottom, I'm going to be writing my final answer, and I'm going to be generating my zeros list, and I'm going to be writing factored form. These will be my final answers. Okay, so one of my zeros is x equals -1/4. Okay, which I'm on my way to finding all of them because my highest exponent I see is a degree 3, which means I should have a total of 3 zeros when I get done. Okay, so let's start generating factored form, you guys. So currently, I'm going to write the factor that I found. So this is going to be f of x equals, now this will be, we do the opposite, so it's negative 1/4 here, so in here it's going to be positive 1/4. Okay, but remember we don't like fractions. Okay, so what we're wanting to do is x plus 1/4, but what we're actually going to do, remember when we have a fraction, we just slide this 4 to the front. Okay, so it's going to be 4x plus 1. Alright, and then we write our depressed equation, which this, I'm going to write it above here as well because we're going to reduce this thing down. Okay, we start with one exponent less than our highest exponent, which our highest exponent is 3. So now I'm going to start with 2. So it'll be 4x squared plus 0x plus 16. Okay, which really, you guys, we don't need this 0 right here. 0 times x is 0, so it's kind of like it goes away. It vanishes. Okay, so what we're actually left with so far is 4x squared plus 16. All right, now remember, you guys, each time we have to try to keep factoring. We must try to factor. Okay, so I'm looking at my depressed equation, or what we got here, and I want to try to factor because if I can, I don't have to keep doing this zeros test. Now, if I can't factor this, okay, what I need to do, there's some options. Okay, when you can't factor this, you need to start, you use the reduced equation, so these numbers down here in synthetic. So my new synthetic would be 4, 0, and 16. Okay, and then I would keep trying things up here until I get another 0 for the remainder. Okay, now, I'm telling you that if you have an x squared, okay, we're getting to a point where we don't really need to do the synthetic division anymore. Okay, if you get it to a quadratic, you can stop doing all this synthetic division stuff. Okay, so keep that in mind. When you get it to a quadratic, quadratic means stop doing this. Stop doing synthetic. We don't want to do it anymore because we are wasting time. Okay, and sometimes, you guys, no matter how many of these we put into the equation and do synthetic over and over and over, we won't get an answer because, remember, there are things called imaginary zeros. And if you see, none of these are imaginary. And when we get it to a quadratic, so a degree 2, this is when imaginary zeros could start creeping up. Okay, so once we get it to a quadratic or a degree 2, we definitely either want to try to factor or just find the zeros. Okay, so let's see if we can factor. So I have two numbers and I'm adding. Now the only factoring technique that has two numbers and is adding, okay, is sum of cubes. So let's see, sum of cubes, we have to be able to cube root each of these. Okay, I can't really cube root a 4. Okay, there aren't 3 of the same number that multiply to be 4, and I can't cube root a 16. It's not going to work. So the only factoring technique I can use on this one doesn't work. So that means we are done factoring. I cannot factor this anymore. It's done. Okay, and since I got it to a quadratic, I know to not do synthetic anymore. I can stop. Okay, so this is factored form, you guys. I can stop. No other factoring technique is going to work. So we've reached factored form. So my final answer for well, actually, I kind of lied a little bit. There is one technique I can use. Do we see anything in common between 4x squared and 16? I think we do. We see a 4 in common. There's a GCF, which don't forget, you guys, we need to pull out a GCF because our leading coefficient in standard form should be the leading coefficient in factored form, which I'm missing my 4. But if you see, the 4 kind of pops out of here. So our final factored form, let's factor out that 4 real quickly. Sorry, guys, I almost missed that. Jeez, Miss Long. So I'm going to factor out the 4. I'm going to write my 4x plus 1. And then I'm going to divide each of these by 4. Let's go. So I'm going to divide this one by 4 and this one by 4. So 4x squared divided by 4, the 4's will cancel. So I'm left with x squared. And I'm going to write this in here. X squared. And 16 divided by 4 is 4. Okay? So, again, we cannot factor anything else because a sum of cubes did not work on that. And remember, there's no such thing as a sum of squares. Demon cats will come after you if you try to do a sum of squares. So now, we have finally reached factored form. Do not forget, you guys, be on the lookout for the GCF. If you get done and you don't have the same leading coefficient as in standard form, you missed a GCF somewhere and you need to find it. Okay? Alright, so this is our final factored form, so I'm going to write that down here in my factored form. F of x equals 4x plus 1, 4 times 4x plus 1 times x squared plus 4. Alright, but you're like, Miss Long, we only have 1 0. We're supposed to have 3 because the degree is 3. Well, guess what? We never found the zeros on this term. We found the zeros for this one. Our first 0 was 1/4, which pertains to this one. So remember, you guys, if you remember, when we have a quadratic, okay, and we have two numbers that are added together, we can just go ahead and set that equal to 0 to find the zero. So let's find the zeros for this real quickly. All right, let's solve this thing. I'm going to bring my 4 to the other side, which the way I bring positive 4 to the other side is by subtracting it on both sides. 4 minus 4 cancels out and turns to 0. 0 minus 4 is negative 4. Okay, so we have x squared equals negative 4. Alright, the way we're going to do a square is by square rooting that thing, which the squared will cancel out the square root will cancel out my squared. So I'm left with x. Do not forget, when you square root both sides, a plus or minus must pop up. The square root of 4 is 2. And then remember, if you have a negative under here, an I is going to pop out. Alright guys, so here are the missing zeros. We have a positive 2i and a negative 2i. Okay, so my other zeros, you can either write as plus or minus 2i. I'm going to separate them so we know the difference. So we have x equals positive 2i and x equals negative 2i, which I don't know why I wrote a 2. Alright, sorry. X equals negative 2i. Alright, so now we have done it because we have a degree 3, and now we have 3 zeros. Okay, so I have 3 zeros, so these are my zeros. And again, it's always nice to write how many real and imaginary there are. So the amount of real zeros, the amount of imaginary, and our total. Let's see if it worked. Alright, well, my total should be equal to the degree, which the degree is 3. Okay, the amount of real zeros I have 1 real, because this one doesn't have an I, so I have 1 real. And I have 2 zeros with I's in them, which means I have 2 imaginary. And guess what, you guys? 1 plus 2 is 3. So yay, we did correctly, yay. So this is my zeros, and this is factored form. We did it! Yay!